Hi. I guess I have the hardest spot in the second day or in the last day after lunch, but let's see how it goes. Hi everybody. My name is Radu. I'm, as Graciela said, a network architect. And I'll try to speak a little bit about, well, networks and network architecture in the new world, because we haven't heard so much about this in the past 2 days. So first of all, to set the stage, a lot of things have happened in the past years, especially in the network space. So a couple of years back, we all of a sudden went home to work from home, all of us at the same time, and it was quite a challenge for networks throughout the world to keep up. And I guess we did quite a good job as an industry, as an IT industry in these past 2 years. So now working from home is the new normal. Everybody is doing that, more or less than some would want, but it's working. One other thing that started happening a while back is that a lot of things that weren't previously connected to a network now are. And this is still happening, and it's one of the reasons why we have all of these security problems, right? Everything is getting connected to everything at the same time, wherever they are or we are. Now, working from Siemens, which is not necessarily the youngest, and it's not quite a startup, right? It has quite a while existing. We are still trying to adapt as a company and to lead this change to the new world. And this is a little bit what I wanted to talk to you about. So first of all, in these days, a lot of things are happening. Some of them are pretty hilarious. So this is actually a real thing. And everybody now has light bulbs. All of you have smart light bulbs at home or other smart things at home, which are not really usually hardened enough or are not state-of-the-art when it comes to drivers and network interfaces and how they handle things. And these kind of things, well, are funny when they happen in a lab or at home, but when they happen in a big company or in a public institution or, God forbid, in an, I don't know, power plant or something like that, it stops being funny. Sometimes it's even a privacy problem. And this is actually a real thing that can happen these days. Well, this is a definition. I am not into this so much into these Zen things, but I find this definition of what Zen is on on Google, and it kind of applies to what's happening to the networks these days, because now everything is connected and everything changes, and we need to pay attention and to learn from what's happening and to adapt the architectures of the networks and of these security systems in order to cope with all of these changes. So what's going on with regards to network security? Traditionally, the way, not only traditionally, I think that to a certain extent it's the status quo even today. We are defending our networks or our locations or our data centers or our assets with something that was thought of quite a while ago. We build a big wall around it. We define walking path that people can, or devices or packets can take through this castle. And at the entry gate, we check everybody that comes in, see if it's a good guy, he's allowed to get in, right? So this is the traditional way of also doing network security. You build a big perimeter, you put in a gate where you control who's coming in, you define some policies there. If that somebody got in, they're good, they're fine. They have access to everything as long as they walk the paths that were defined. But actually, the new world looks more like this. So there's no really a wall anymore, and you don't really know where everything is going and where the bad guys are, or who is inside each one of these, we call it attack surface today. So in this new world, one of the approaches that is widely popular, and it's called zero trust. It's what I want to talk about. It's a very good thing that actually this is happening. Wanted to look at this totally different, say, forget all this network security. We cannot do it anymore. Let's change a little bit how we do things and just define some principles. And we started from They started when they defined the standard, actually, from simple things, like you should always assume that something has been breached when you design networks and architecture. You should never allow a user, a device, or something, or somebody to have more access than they actually need in order to get their role or their job. You also need to do smaller segments in the network and in security space. And normal things like multi-factor that now I won't talk about because everybody uses it these days. And this somehow translated into, well, a standard. Whoops. I think I'm missing a slide. Bear with me. OK, I'll talk through it. So basically, the idea of zero trust is that a standard has been defined by a well-known institution in the United States that's called zero trust architecture. What that said is that in order to make everything safe, you should forget all of these controls that are placed everywhere and follow some simple rules. And an architecture should be defined with some elements, and I'll let you read through that because as any standards, it's quite cumbersome. But there are some basic things that were defined which are quite important these days. One is that you should never grant somebody access to anything based on where they come from. So the traditional way of doing things is that in many locations or companies, if you're inside the network, you get attached, maybe you get authenticated, maybe not, depending if you're on wired or wireless. It doesn't matter. Even if you are authenticated, the de facto standard is that you get access to the network. You get a link, you can get access to anything. That's gone. We are moving away from that model. Some other pretty important things are related to zero trust, like you should always authenticate everything, and after you authenticate something, you need to authorize if they are entitled to access that application. One other thing is that everything should be encrypted, and the good old log everything and look at the logs and monitor everything. The motto of the zero trust architecture is never trust, always verify, which is all good and fine, and it's an approach that has been widely adopted, at least as a strategy, by many companies in this world. And what does this mean now talking on behalf or as a representative of a company that does industrial things? There's another side to it. And that side is driven by the fact that, as most of you know, the life cycle of an industrial thing, whatever it is, and I don't know, an automation line, a power plant, an MRN scanner, whatever it is, a train, the life cycle of such a thing, it's much bigger than your usual IT life cycle. So it's something that you invest a lot in as a customer, you live with it, and you take advantage of it for, I don't know, 10, 20 years, in which time you don't usually get the chance to do any patches. And the guys that have been developing it at the beginning are not really keeping things up to date. And that's normal. And the way this has been approached traditionally was physical security. Nobody reaches the control part of our power plant. It's physically there, it's separated, nobody gets in there, only the technician that knows what they are doing. But now, also with the pandemics and with the changes, things are also happening in that space. So now, many vendors of such industrial devices and maybe subcontractors of that vendors are asking for remote access. And that doesn't exist because it's physically separated. And we end up, number one, with very not so funny situation in which somebody operating that device is really getting a DSL line from somebody, from a service provider and connected to that in the public internet, to that whatever it is, control part of our plant, and it gets its vendor access there, which is not funny at all, and I guess many of us have seen these kind of things happening. On the other hand, all of these smart devices are also triggering the industrial world where everything needs to be connected to the cloud these days. So this is scary. The fact that industrial devices are getting connected to the cloud, to the internet, and access from outside, it's scary. And this zero trust pillar is one of the key things that we are looking in Siemens for the future to be the de facto standard. So basically, what this means is that, and by the way, this doesn't apply just to Siemens products or to our internal network or to the way we approach our customers or to our data centers and so on. It's supposed to be an overarching strategy that applies the same rules everywhere. And the couple, how do we do this? Because it's hard to, if we have separate entities, separate rules for internal networks, separate rules for data centers, separate rules for workers from home, for products towards our customers, it becomes complicated. So the idea was, let's do things simpler, simplify them. Apply that never trust, always verify everywhere. And an interesting part, internet everywhere. What does that mean? We are turning a little bit around how things are working. So since everybody started working from home, you know, that initially 3 years ago, that existed, that always existed. Working from home was always a thing, but it was for that lone wolf account manager that was out there somewhere in the middle of nowhere, and it was okay because it was limited exposure. These days, everybody works from home. What that triggered in many companies, in many public institutions, was that the end devices weren't hardened enough, and these same zero trust principles of authenticating and authorizing are being, to an extent, applied. So then what we are trying to do, and we are rolling out in our locations, is that we turn things around, and instead of trying to overcomplicate our intranet or internal network, we said that, look, all the managed devices, the laptops that we are using, or Siemens employees are using, they can be used from home. It's the last 2 years were a proof of that. So let's then turn it around and offer those employees and those devices the same user experience that they get at home at the office, which means that for our employees and for the managed devices, basically when they come into an office, they get the Starbucks hotspot experience. Of course, it's everything that an enterprise should have on top of that. Secure internet access, cloud optimization, and so on and so forth. But at the end of the day, it's the same experience. But now, somehow in all this, the expectation from many, the expectation from the majority of stakeholders was that after you introduce this new thing with zero trust, which kind of define rules around how you write applications, how you expose them, how you enforce clients to access the application, and so on. So when you do this, somehow there was the expectation that the network would not necessarily become obsolete because everything is connected to everything, but it will become flat, right? Everything will be connected to the same wide internet. You'll get access to everything. Everything will be hardened from application level because it's zero trust compliant, and everything is simple. So in all our experience, I guess, we learned that one single tool or one single architecture, one single set of rules is usually not the one that can solve everything, like in that movie. So then, what about the network, which I have been doing for the majority of my life, network architectures, and it's still my hobby. So the question somehow is haunting. Is the network still relevant? Because all these zero trust measures are covering now everything. And looking at how traditionally network security was defined, we don't have a place to put controls anymore. Not in the same way that we were doing before. But there's a but here. As long as people write code, well, it will have bugs. So then all these zero trust principles, if you just rely on application level security, then things will happen. And at the same time, not only that the bad guys are everywhere, but they have connectivity towards multiple destinations from multiple points. And if the network is flat, then... So you get where I'm going. The answer to the question, is this client-server application hardening enough? I guess not. So I think that the network is still relevant, and we'll explore that a little bit. There's another side of it. as I touched on earlier, these devices that have a long life cycle usually don't get updated very often. So even if you define a strategy, you'll end up with maybe a long development cycle until you launch the next industrial thing that has the capability to be zero trust compliant and written following these rules. There's the other side of it, that there are many vendors that are competing on pricing. You see those smart light bulbs or maybe security cameras or stuff like that. Those type of vendors will never have the development power, R&D, Q&A, testing, and all of that to make sure that everything is hardened enough. So bottom line is that we will, I guess for the foreseeable future, still have clients and applications which are not zero trust compliant. So how do we close all this circle? So network to the rescue, right? I really think that modern network security adapted to these principles and to this landscape is critical in this new world. So first of all, we should remember and keep in place everything that exists. So the changes in the network security architecture driven by these new zero trust principles, it's not about removing controls. We should not get rid of everything that we have and make a revolution. It's about evolving what we have. And there are, I guess, three main pillars that I'll bring up a little bit that I think are the keys about the evolution of the network in this context, in this zero trust world. So first, one of it is SASE. I don't know how much you have heard about it. We'll get back in the next slide. The second pillar is around how we segment our networks and how we reduce the attack surface by enforcing policies on this segmentation. And the key here is that if we do things traditionally, and I'll get back to that, we won't get very far. And the last and not least is software-defined. Many of us have heard of software-defined networks. I will get back to that in a bit. This is actually the most important part, the most important change, because what it brings with it is the capability to use the networks as we have them today just as an underlay, meaning just for transporting packets, and define overlays on top of that that are much more dynamic and can be better controlled. So one by one. So SASE stands for Secure Access Services Edge. Somehow, this is also I don't know if I should call it a hype, but it's a buzzword these days. And all the security vendors, I think you have heard of some name, Zscaler, Cisco Umbrella, and so on, Prisma Access from Palo Alto. They are offering these solutions, and they are somehow marketing those as being the one thing that the enterprises or companies or public sector entities need to implement in their network in order to change everything and become zero trust compliant. Well, it's not quite that, but it's a very important pillar. So what this is, what it was sort of being, this new architecture, it's actually a new architecture for remote access, but it's different from what you have used so far, from what we have all used so far. So how does remote access look traditionally? You have somewhere an VPN gateway, if you want to call it, concentrator. You would build from your client a tunnel up to that, and then it's like in the traditional connecting with the wire in the intranet, you get access to everything else afterwards inside. So that's the traditional network approach. This new approach is about using somehow a cloud-driven front end towards your customers, and you will build an application layer, an application overlay on top of that. So you can look at this as being an if you want a smart and encrypted application level proxy in which the end customers, maybe employees working from home or working from the office and just getting internet access, as I explained earlier, they would have a client that is application aware and can route applications with using this overlay towards applications that are hosted inside of the gates of the enterprise. Now, one of the most important new things, getting back to the initial picture of how the new castle looks like, is building those small red bubbles around each one of the elements of the new castle. And how do we do that? Because traditionally, how do we do network segmentation traditionally? We take the layer, the LANs inside locations or data center, we split them in layer 2 domains, VLANs. We put a subnet on each one of these VLAN, and maybe we apply an access list on each one of these VLANs, defining who can come in and who can go out. Maybe we even place a firewall there. And the new world is very, very different, because the way it works now in the networks is that whenever a device is attaching to the network, it first goes through, and so it connects to the underlay, so exactly to the first layer. So before getting network access, that device is being authenticated. Maybe the user using it is getting authenticated. There are a number of ways to identify who that device is, maybe with an agent. After that is being done, that device is being mapped to a so-called microsegment. So some vendors call it security group, some other call it roles. The idea is that this is a multi-site, cross-segments, cross-traditional segments, cross-subnets, cross-VLANs thing. So one of these microsegments can spread across all of your sites, across all of your buildings in a campus, or across all of your floors in a building, and so on and so forth. And all of those devices in that microsegment can be uniquely identified with a tag, with an ID. It doesn't matter. This new ID is actually something that's being transported on the overlay created with software-defined methods. And this is a very big thing. It's a huge thing, actually, because imagine that. You have 4 locations and some data centers. Here you have HR users, and you have some HR applications. Traditionally, you know how it goes. You define the HR users in each location, go to a certain subnet, then you take the firewall in front of the HR applications, you define an access list there, and you maintain all of that. What's the problem with that? If you look at those firewalls, 3-4 years down the road, you will end up with a list of, I don't know, 20,000 entries in an access list, and nobody knows what those are doing, and nobody can remove them. And it's extremely hard to maintain. On the other hand, when you add a new building, or when you extend your applications, everything is complicated. And getting back to this microsegmentation, why is it such a big deal? Because now it's called business intent. You can now actually define in the network platform, in the policy definition point, just one rule to allow for this communication that says HR users or HR user microsegment can access HR applications microsegment. That's it, one line. Not only that it's extremely easy to maintain, it's easy to understand what it does, and you decouple somehow the policy definition from what are the sources and the destinations, which is actually getting us back the control that we had initially with the wall against the castle, but in an extremely dynamic and easy to maintain way. Now, in this new world, what actually makes all of this possible is the software-defined networking, which has been somehow an academic thing initially. So originally, it was thought to be something else. Today, it's the tool that allows us to create overlays to make things dynamic and not to need to define anymore those static and IP-based rules in the network. And because not everything is simple, there are multiple software-defined platforms, different ones for different scopes. So you can have one for your campuses, so for where users are, for where your locations are, one for the data center. I think many of us heard of SD-WAN, which is a standard one thing in enterprises today. And the idea is that for each one of these domains, there are some rules and some things that will apply. So for example, for the campus part and production area and devices, IoT areas, as I said initially, we'll need to identify everything before connecting to the network, put them in segments, in microsegments, and applying the authorization part. For the branch and WAN and SD-WAN part, it's important to do a couple of things in order to not have the users complain that the network is not working well. So number one is to be smarter in the way we route traffic in the network. So the SD-WAN somehow includes doing application recognition, which means that, as a simple example, when I have users in my locations wanted to access, I don't know, Office 365, I don't need to put them all the way back to data center, apply their policies, and break them out there. I can do it locally, directly. Why? Because I know Office 365 is a zero trust compliant application that is already integrated with my backend, and I can trust that the traffic can go over the internet directly. It will be encrypted, everything will be applied, the rules that I define. The other thing which is important in the new WAN is that I will be able to apply a different type of QoS if you want. It won't be packet-based. So initially, the traditional QoS works by prioritizing some type of traffic over another in moments of congestion. Now, with the new tools that I have at my disposal with SD-WAN, I can do some different type of QoS. For example, I have this big, cheap internet pipe that I only use for scavenger applications, like, I don't know, employees watching YouTube commercials. And I have this more expensive, maybe an MPLS pipe, where I route my critical applications. And the nice part is that using central orchestration, I can do things like, if all of a sudden YouTube becomes a business critical application because maybe I have the trainings on it, I will be able to just, with a couple of clicks, define, look, the YouTube traffic now, it's not scavenger, move it to the more important link, so everybody is happier, including the one that wanted to do training on YouTube. So since I only had 2 more minutes, I'll end with a, whoops, wrong button, with a thank you. And if any questions, please.
Thank you very much, Radu. We have a question.
Hi. First of all, I just want to say that your passion really comes through. Thank you. Really great talk. As you mentioned, the landscape is fundamentally changing, and with that, the role of a network engineer is definitely changing, right? We're moving from one model to another. What would you say are individual contributor level skills that people should focus on as we move from the way we used to do things to the new way that we're apparently going to do things? Thank you.
Thank you. Very good question, because actually it's even more complicated than that. It's not just internal users. At the same time, there's this big move towards outsourcing of all IT and of all networking, so things happen in parallel. And usually the service providers taking it over are not really much more equipped than the users inside. But just to answer your questions, I think that the main new point that the network engineer should take in is to understand the new technologies around software-defined things. And the reason for that is that it's fundamentally different. So you would say an entry-level junior engineer, initially, if you would go and tell them, look, you need to change this 1,000-site QoS mapping, they will say it will take half a year, I'll do it hand by hand on each one of them, plan the changes, and so on. Maybe a more senior one would think about scripting and doing some sort of a hand-built application. But in these days, if you get it right from an architecture perspective, and you couple all these software-defined worlds together, you can actually do changes with just a couple of clicks. I'm not praising the GUI and get lit of CLI, because we should also have employees that know how things are going. But when it comes to how to apply changes and also how to apply security from that perspective, things are much easier and much more dynamic and much simpler with the software-defined platforms. And some of them are more mature than others. So for example, I think that software-defined WAN is about there with the maturity. Data center software-defined networking is in its bloom somehow, while with the campus part, we are still at the beginning. But in terms of fundamental shift in how network engineers think, understanding these new things, it's key, and how to use them, because there's another challenge to it. Usually, network engineers are very afraid, at least I would say the more experienced one, are very afraid of these platforms when you do 3 clicks and it changes everything in your network. And they should learn to live with that, because it's how we'll need to do things in the future. But thank you, nice question.
Thank you very much. I can see another question there.
Of point of view of security, not commercial, do you think that it's better that the network equipment producer to make updates on firmware software many years, not only 5 years, 3 years?
Yeah,
Okay.
I think, thanks. I understand.
Because we a lot of configuration, a lot of, you know.
Yes. So just to play it back to make sure I understand correctly, you're asking about the level of support and the updates that the network vendors are keeping for their equipment, correct? Okay. So basically, it depends because some equipments have a longer life cycle than others. However, I think what's extremely important there, apart from what the network vendors are doing, because we have limited leverages with them, I think it's very important to maintain healthy processes and healthy rules and way of approaching things inside companies, inside public sector, inside enterprises. And things like making sure you don't have equipment that's end of support and nobody does patches for it anymore. It's very important. So I would say, yes, of course, the network vendors should do much more for us because we are paying them large amounts of money. Everybody knows that. But there's also, I firmly believe that we should also look at ourselves and see what we can do better and what's easier to do. And keeping healthy rules about how we maintain software, how we maintain patches, how we do patching, how we keep equipment in support is even more important.
Who is not good, so good, and make a worse configuration. And in point of view of security, is not good.
No, it's not. And these things will always happen. I think that to a certain extent, this new software-defined world will help, because as long as you decouple this underlay and overlay, you should be safe, because the overlay part, the security part that is actually user-facing or application-facing is now moved to something that's automated and orchestrated. And usually the engineers are just creating the underlay, which exposes less from a security perspective. But you're right. So things can be improved there.
Thank you very much for the questions. I guess we have time only for one more question, one more short, if possible.
How do you mitigate identity stolen, something?
Sorry?
How do you mitigate if a user password is leaked?
If a user password is stolen? That's the question, right? Okay, I won't go to MFA because that's the obvious answer to that. So the key there is to define the policies in a way to map endpoints to microsegments, not just user-based. So usually there's a combination. You need to authenticate the device via a certificate somehow. Then you authenticate the user. There's ways of doing that today with YEP chaining and so on. And on top of that, you also look at the posture of that device, meaning it has the right level of patches, antivirus, and so on. You're just decreasing the risk, obviously. Everybody will be able to store passwords, as we have heard earlier today. And apart from mitigating how you authenticate that device, there's also the key factor that these new microsegments, new segmentation way, is really decreasing a lot the attack surface. So even if a credential, the principle is even assume breach, you know, from my second slide, assume you have a breach. So then you have such a small attack surface that usually you'll just get devices of the same security sensitivity exposed after you get such a breach. But as with security, you can never be 100% safe.
Thank you very much for the questions. Thank you very much, Radu. I guess Radu will still be available in the lobby if you have some additional questions. And now we can move for the, thank you very much.
Thank you.
And a round of applause for Radu.